Amid an unpredictable geopolitical climate, Russian aviation has delivered a major shock with a remarkable achievement: the successful creation of the PD-26 engine, a cutting-edge power plant poised to shape the future of both military and civilian aviation. Announced by Russia's first Deputy Prime Minister Denis Manturov, this development is not only a demonstration of Russia's technological strength, but also a wake-up call to the West, revealing the country's rapid progress in aircraft engine manufacturing. So, what exactly is the PD-26, and how could it challenge the West's long-standing dominance in engine technology? Let's explore. The PD-26 engine is the product of a smart development strategy, building on the successes of its predecessor, the PD-35, to address current needs and advance Russia's technological self-reliance. By leveraging proven technologies from the PD-35, Russian engineers shortened development timelines while ensuring reliability and performance. To understand the PD-26's importance, we first need to revisit the PD-35. This high-bypass turbofan was designed for Russia's long-range, wide-body aircraft. With up to 35 tons of thrust, it represented Russia's first engine of its type in the modern era. Engineers invested heavily in core technologies, including a massive 3.1-meter diameter fan and a highly efficient high-pressure turbine system. Its fuel consumption was 2 to 5% lower than Western competitors, and nitrogen oxide emissions were 50 to 60% lower, proving the engine was both powerful and efficient. On test stands, the PD-35 reached its full 35-ton thrust potential. Chief designer Alexander Inazev noted that increasing the gas generator size by 15% could push thrust to 50 tons, showing the enormous potential of this platform. This is why the PD-26 with a 26-ton thrust rating is so strategically important. Instead of developing a completely new engine, Russian engineers reused the proven PD-35 gas generator. This not only saves time and resources, but also guarantees performance. Choosing a 26-ton thrust was carefully calculated to suit both future military transport aircraft and wide-body passenger jets. Manturov emphasized that designing an engine for just one modernization program would be too costly. Therefore, the PD-26 was built as a flexible platform with potential for ground-based applications, ensuring both profitability and sustainability. With more than 20 advanced technologies incorporated, the PD-26 is more than just an engine. It symbolizes Russia's aerospace capability and long-term strategic vision. The PD-26 comes at a critical time for Russia, whose military transport fleet faces serious challenges. The backbone of Russian airlift capabilities, the Antonov An-124, is aging and heavily reliant on foreign components. Although 26 aircraft are officially active, only about a dozen are operational. This has caused problems, especially as the military operation in Ukraine has sharply increased demand for transport aircraft. The An-124 aircraft use 4 Progress D-18T engines, each with 24 tons of thrust, which were originally manufactured in Ukraine. Since 2014, technical support and spare parts have been cut off, forcing Moscow to overhaul these engines domestically at the Ural Civil Aviation Plant, or USGA, and, produce spare parts locally. Defense Minister Sergei Shoigu aims to double the operational fleet by 2025, but honestly, this is just a temporary solution. USGA is under a 3-year contract to overhaul 60 D-18Ts, but this only addresses immediate needs. The PD-26 represents the long-term solution. During a visit to the Aviastar plant, Shoigu asked about engines for a future 100-ton transport aircraft. Lieutenant General Vladimir Benediktov, commander of military transport aviation, said 2 options were being considered: a modernized D-18T or a new PD engine. This makes the PD-26 the likely replacement. With 26 tons of thrust, it surpasses the D-18T in power, while being significantly more efficient, making it, ideal for modernizing the An-124 fleet. But, Russia's ambitions go beyond just replacing old engines. The PD-26 is designed to power a next-generation super-heavy military transport aircraft. The IL-100, a 100-ton transport intended to replace the aging An-124s. Codenamed Slan, which is Russian for elephant, the IL-100 is part of the prospective aviation complex for military transport aviation, or PAC-VTA, reflecting Russia's drive to fully modernize and really achieve self-sufficiency in strategic airlift. So, initial details from patent filings actually show that the IL-100 resembles the American C-17 Globemaster III, with a high-wing layout, 4 engines under the wings, and a pretty distinctive tail. This design, well, it enables operations from short, unprepared runways. It also features a large rear cargo door and an upward hinged nose section, which is ideal for transporting heavy or bulky equipment. Russia is aiming for a versatile aircraft here, capable of moving troops, vehicles, electronics, and weaponry efficiently. When it comes to engines, analysts agree that the PD-35's 35-ton thrust would be, honestly, overkill and uneconomical. The PD-26, providing 26 tons per engine, is just perfect. 4 engines would deliver 104 tons of total thrust, which is suitable for lifting a 100-ton payload while optimizing fuel efficiency and operational costs. Deployment will likely follow a 2-stage plan. Initially, to meet urgent transport needs, the IL-100 may use modernized D-18Ts temporarily. Later, mass-produced versions will be equipped with the PD-26, allowing Russia to perfect domestic engine production without disrupting operations. This strategy addresses immediate challenges while ending reliance on foreign technology. The PD-26 isn't just a technical achievement, it's a strategic milestone, signaling Russia's resurgence and self-sufficiency in aerospace. It ensures technological independence despite Western sanctions, modernizes the military transport fleet, supports economic growth by creating high-quality jobs, and strengthens Russia's position as a global technological and military power. For the West, the PD-26 is both surprising and concerning. The speed and scale of Russia's progress challenge decades of Western dominance in aircraft engines. Moscow's ability to produce powerful domestic turbofans changes the competitive dynamics of global aviation and forces a reassessment of Western strategies. So, in summary, the PD-26 is a symbol of Russian aerospace resurgence. It solves historical challenges, enables next-generation aircraft like the IL-100, and really reinforces Russia's position in global aviation. Meanwhile, Russian civil aviation also made headlines. The Superjet 100, powered by the domestic PD-8 engine, completed its first test flight on March 17, 2025, over Komsomol-Skamor. This flight marked a step in reducing reliance on Western components under Russia's import substitution program. Piloted by Dmitry Manov, Gory Grezv, and engineer Maxim Griala, the aircraft reached 500 kilometers per hour at 3,000 meters. The PD-8 operated smoothly, gathering key aerodynamic data. The PD-8 delivers 8 tons of thrust designed for the Superjet and B-200 amphibious aircraft. Developed with advanced technology from the PD-14 series, it represents extensive collaboration under Rostec's Import Substitution Initiative. Certification is expected by fall 2025, paving the way for mass production. Beyond just replacing the engine, the SJ-100 still needs to complete around 200 test flights and swap out more than 40 foreign components before it can get full production certification. Russia is also working on the MC-21, which could become a real competitor to the Boeing 737 and Airbus A320. This new aircraft is expected to use the PD-14 engine, marking another big step towards self-reliance. More than $2.7 billion have already been invested in domestic aviation, and full production of both aircraft is planned for 2026. The PD-8 is more than just an engine. It's actually a symbol of technological independence. Russia used to rely on the French power jet Sam-146, but now, with the superjet, they're showing they can really stand on their own. Localized production means easier future maintenance, export opportunities, and way less dependence on Western supply chains. So, the PD-8 comes with a 1,228mm diameter fan with 24 blades, a 3-stage low-pressure and 7-stage high-pressure compressor, a heat-resistant combustion chamber, plus a single-stage high-pressure turbine and a 3-stage low-pressure turbine. Composite materials help cut down on weight and noise. The thrust reverser uses an electric drive, and the engine is managed by a full-authority digital system, or FADEC. Standard thrust is 7,477 kg force, and it can go up to 8,056 kg force in emergency mode. Compared to the SAM-146, the PD-8 delivers better fuel efficiency, improved durability, and more potential for future upgrades. Although the PD-8 is a scaled-down PD-14, challenges remain, like optimizing airflow, fuel efficiency, long-term reliability, and of course, mass production quality. Global competitors include General Electric's CF-34, Rolls-Royce's BR-700, and Pratt & Whitney's PW-1000G. While the CF-34 is just a bit more powerful and has a vast support network, the PD-8 is catching up quickly, providing a domestic alternative for Russia's civil aviation needs. In conclusion, the PD-8 really represents Russia's technological independence and ambition to compete with Western engines. If it proves reliable and efficient, it could meet domestic demand and even serve export markets in countries looking for aircraft free from Western control. Every turn of the PD-8's fan blades propels Russia's aviation industry into a new era of self-sufficiency, pride, and technological confidence. So, Geotalk fans, do you think the PD-8 can truly compete with Western engines? Share your thoughts, and as always, thanks for watching. Have a safe flight.